Notes for 15.3 are about bonding in metals. We have done ionic compounds, which consist of a metal and a nonmetal, and you see a transfer of electrons. And we've done covalent bonding, which is between nonmetals, where we see a sharing of electrons. Metallic bonding is a little bit different. Metallic bonding actually consists of the attraction of free-flowing valence electrons. Remember, your valence electrons are your outermost electrons. For the positively charged metal ions. So, if you were to look at a piece of metal, it's all connected together. It's a solid, very tightly packed. And what you have is the center of your iron, let's say it's iron, of your iron atom. The center, of course, is positive, and so you have all of these together as a solid, arranged, tightly packed, vibrating in place. It becomes positive because on the outside you have all your valence electrons. Again, your valence electrons are completely free to move around. So the electrons that I'm drawing now, this electron might have been from this atom originally. What happens is they are just free to completely move around. Sometimes they call this a sea of electrons because of their ability to move throughout the whole sample. Now it's this idea, the sea of electrons, that are responsible for all the properties of the metal. Again, what are the properties of the metal? We've talked about properties of metals before, so junior high, elementary, you've heard all of these before. So you have your properties. You have very high melting points. Okay, we've talked about that before. They are ductile. Remember, to be ductile means pulled into wires. In other words, it can be shaped. They are malleable, which means they can be hammered into sheets. And they are very good conductors of electricity. And of course, since they are tightly packed and arranged in a 3D pattern, they do have, believe it or not, crystalline structures. Okay, so these are all the properties of metals. And again, all of these properties are due to the movement of electrons. So we can really see this. I mean, as far as high melting point, it just means that because those electrons can move freely, they have a very strong attraction for each other. Much like an ionic compound, which is what makes their melting points high. It takes a lot of energy to separate those when they're sharing all of these electrons. Okay. Now, ductility, malleability, the ability to actually rearrange the shape is very key. What I'm going to try to do here is switch over to the book so you can see a better drawing than what I can do. All right. So if you look right here, this is what our metal looks like. Let me get a little bit closer so you can see a little bit better. Let me get it focused here for us. All right, so this is your metal. You've got your positive ions, your positive metal ions, and those little yellow dots, if you can see those are your electrons that are free to move around. Now, you can hit these, and the metal changes shape, but it still remains in one piece. Okay. Here's an example of an ionic crystal. You always have every other one in terms of charge because the opposite charges attract. Now, if you were to hit this with a hammer or force it through a device to make a wire, it would shift these. Well, if it shifts these, it will align a negative with a negative, a positive with a positive, and a negative with a negative. And we all know what happens when you get like charges together. They repel. And when they repel, that causes the crystal to shatter. So it's going to break apart. So ionic compounds are not malleable. They're not ductile because of that. But if you were to, when you shift this one down, yeah, the positives move down, but they're still surrounded by their valence electrons. So they're not going to repel from one another. Also, in terms of conducting electricity, why are they able to conduct electricity? Well, ionic compounds can conduct electricity if they're melted. Because if they're melted, these are free to move. Or if they're dissolved, they're free to move. In a solid, they're not. Well, when you have a metal, all of those electrons are constantly moving already. And electrons are charged particles. So as long as you have charged particles that are free to move, it will conduct electricity. So those will conduct electricity. All right, getting back to our notes, the only other thing that we need to describe are alloys. Messed up my camera. Moving on. Back to the notes. All right, so an alloy. Okay. An alloy is actually a mixture of elements, one of which is a metal. Okay. We have lots and lots of examples that we can talk about. Some of the things that we see every day as alloys would be your silverware. The silverware that you have at home is actually called stainless steel. This is a mixture of iron, chromium, carbon, and nickel. Okay, we've got our iron because it's very, very flexible, but the problem with pure iron is that it rusts really, really bad, very, very easily. So you throw in some chromium. Chromium is very rust resistant, and it has a nicer shine to it, and so that gives it that property. You got to remember these are mixtures, and when you have a mixture, everything holds on to its own properties. You don't get new properties. This isn't a chemical reaction. They add carbon. Carbon helps to make it just a little bit stronger, gives it a stronger structure inside. And then, of course, nickel is another type of metal that is shiny and helps to keep it from rusting. Okay, so here's a mixture of many elements in this case. If you were to look at cast iron, of course, that is also an alloy, but cast iron only has iron and carbon. Now, granted, again, it's mostly iron, but if you have had experiences with cast iron pans, if you leave any water in it, it does rust fairly quickly. Okay. The carbon is just there for the extra strength. So there's a lot of different types of alloys out there. Sterling silver is another one. You mix silver with copper, and we use sterling silver for jewelry. You have gold. You've got your different golds. So here, let me flip this page over really quick. If we are talking about gold, if you have 24 karat gold, that's pure. But if you have 14 karat or 10 karat, these are mixtures. Again, they like to mix in typically copper to make it stronger, sometimes silver, but metals that are worth some money, but it makes it stronger. Pure gold is very, very soft. It bends very easily, so if you had a ring, you could squeeze it and basically cause it to change shape, and that's not good because it could get stuck on your finger that way. So why are alloys so important? Again, it's going to combine the properties of the metals or substances, we'll say, because they don't have to be all metals. It combines the properties of those substances, which makes a better product. It makes the whole thing better, more useful. A better way to say this might be to say that their properties are superior. Okay, so new. Okay, properties are superior to the original or the individual. There's some alloys that we don't use very often anymore, but they have some special names, one of which is called an amalgam. An amalgam is a mercury-based alloy. Okay. Well, as I run right off the page, it is a mercury-based alloy. This used to be, if you took mercury, here, let me just write the symbols. Mercury mixed with silver. That's what our old fillings were made out of for our teeth, mercury and silver. Now, mercury we know is not good for you. However, when you mix mercury with silver, it keeps it from entering the blood system. It kind of holds it in, and so it's no longer poisonous to you. And then mixing the mercury with the silver, it makes the silver more malleable, so it can form better to the tooth. But now they don't use those. So those are just some things that have been out there. And if you go to your book, they've got some more examples. Like you can talk about brass. Your brass instruments are mixtures that have copper and zinc, I think it is. I always get those two mixed up. And then you've got bronze, which has, what does it have in it? Copper and tin. Okay, so brass and bronze look kind of similar, but they do have different properties. But those are things that you might be a little more familiar with every day. So alloys, mixtures that contain at least one metal, and they're so useful because it makes their properties more superior.